Today, I want to introduce to you the fault domain and protection domain technology in our ONEStor distributed storage product. You may have heard of ONEStor before. ONEStor is a distributed storage software product of H3C. It uses a leading fully distributed architecture. It had the advantages of high reliability, powerful linear scaling capability, flexible partition storage characteristics, and automated operation and maintenance capability. ONEStor can be installed and deployed on a cluster consisting of at least 3 servers. The local hard disk storage resources on each server are combined into a unified storage resource pool, and the storage volumes are divided according to needs from this resource pool and provided to clients' use. ONEStor provides a simple, beautiful, and powerful monitoring and management interface. Here you can see ONEStor storage usage, cluster health, business, cluster host hard disk, memory, CPU status, and other information. The current status of the cluster is clear at a glance, which is convenient operation and maintenance engineers discover and respond to problems in time. For storage, a particularly important feature is reliability, or in other words, data security. Because data is priceless, storage must ensure that the data stored on it will not be lost due to a single point of failure of the hardware. So, how does ONEStor achieve high reliability and protect data security? In ONEStor, a multi-replicas mechanism is adopted. That is, multi-replicas of the user's data are stored in the storage medium. For example, a typical 3 replicas means that one replica of data is stored 3 times. In this case, only 3 replicas of data are lost. The user's data will be truly lost. Speaking of this, you may have questioned that if 3 replicas of my data are stored on the same server, and that server fails, then all replicas of my data will be lost at the same time. So, in this case, how to ensure data security? To answer this question, it is necessary to understand the concept of fault domain in ONEStor distributed storage. As the name suggests, a fault domain is an artificially divided area to isolate faults. It is the smallest unit of data distribution in a ONEStor cluster. For the same piece of data, it has several replicas, which will be distributed in several different fault domains. OneStor's fault domain tab is optional, divided into 2 tabs, host and rack. The rack here is a user-defined logical concept. During deployment, the user can specify any host to be located on any rack. However, because the hosts on the same physical rack are more likely to fail at the same time, in order to better isolate the faults, it is recommended to choose according to the actual distribution of the hosts. When the fault domain is set as a host, the several replicas of a data will be distributed on different hosts. In this case, when a host fails, all replicas of the data will not be lost. However, since all replicas of the same data may be stored in the same rack, if the entire rack is powered off, this data will become inaccessible. When the fault domain is set as a rack, the several replicas or fragments of a data will be distributed on hosts in different racks. In this case, all hosts on a rack can be tolerated at the same time failure, such as power failure of the entire rack without affecting data security. Therefore, when the cluster is large and there are more racks, it is recommended to set the fault domain to the rack. Also note that there must be at least 3 racks in the cluster before the fault domain can be set as a rack. In addition to fault domain, there is a means to improve data reliability in ONEStor, which is protection domain. The protection domain is a logical concept and a further subdivision of the ONEStor cluster. The ONEStor cluster can be divided into multiple protection domains. The protection domain and the fault domain are strongly related, and the smallest unit of data distribution in each protection domain is still the fault domain. It should be noted that, according to the type of fault domain, there must be at least 3 hosts or racks in each protection domain. For example, if the rack is selected as the fault domain, we can designate several racks as a protection domain, and all replicas of our data will be stored on different racks in this protection domain. The advantage of a protection domain is that it isolates faults. If a fault occurs in one protection domain, it will not affect the data in other protection domains, thus further improving data security. When a fault domain is set as a rack, consider the simplest 2 replicas policy method. When the protection domain function is not turned on, the entire cluster can allow any one rack to fail without data loss. If the second rack fails at the same time, it may cause the loss of part or all of data. If the protection domain function is turned on, and the cluster is divided into 2 protection domains, each protection domain can allow one rack fails without data loss. Only when 2 rack failures occurs in the same protection domain at the same time can data loss be caused. In this way, the entire cluster can allow up to 2 racks to fail, which further improves reliability compared to not enabling the protection domain function. Through the previous lecture, the introduction of fault domain and protection domain technology and configuration in ONEStor distributed storage is complete. Let's review the main points of today. Number 1. In ONEStor, different replicas of the same data are stored in different fault domains. Number 2. In ONEStor, all replicas of the same data are stored in the same protection domain. Number 3. The fault domain and the protection domain of ONEStor are configured during cluster deployment. Once the cluster is deployed, modification is not supported. That's the end of today's lecture. Thank you.